Hi all, I'm going to share a video with you about two of our newest strategies in division. These are strategies that will follow us into fifth grade and are kind of building the idea of long division. So they're becoming more efficient. They're building on students' understanding of place value and also multiplication facts. And so it's kind of putting a lot of different math ideas together in order to have an efficient, accurate way to show our thinking. So the first strategy I'm going to show you is an area model strategy. The second strategy I'm going to show you is what's called a ratio table. Both of these we've used in multiplication earlier in the year and throughout the year. Now we're moving these same strategies into division. So the other nice thing is that students can use them in both types of math and they use them very similarly. So it's building on a strategy that they already hopefully have. So hopefully you'll be able to hear me. I'm actually using my big screen. So the video of me in the little picture of me in the side here, I won't be looking at the camera, but you'll be able to see what I'm doing on my screen. So I want you to imagine we have a problem such as we know the area of, let's say, a garden plot. And we know one of the dimensions, but we don't know the other. So for example, if we had a problem like, let's make sure that I've got the pen. If we had a problem like 252 divided by 12. This would be a problem because it's using area that an area model could be a good strategy for this. So what we do is we end up drawing what's called an open area model. So you'll see on the right side that I don't close my area model, but I know that my area, the inside of this garden plot, needs to equal 252 square feet. And I know that one dimension of my garden plot is 12 feet long. So what I'm going to do is I'm going to take small chunks, small steps towards getting to that total of 252 square feet. And we talk a lot about using landmark numbers. So numbers like 5, 10, 50, 100, and so on, because these are easy problems to compute. So I'm thinking about the number 12. It's a 2-digit number and I want to get it to be in the hundreds. So I'm going to start with a landmark number of 10. And if I had a garden plot that was 10 by 12, it would have an area of 120. And so I'm constantly checking back. Am I at that 252 yet? No, I'm not. And I think I could do that again. So I could make another section of the garden plot that's another 120 square feet. Together right now, I would be at 240 square feet. So I'm having to go back and doing some adding. And then I can also now compare again to 252. Well, I see that I'm only 12 away. And so if I need an area of 12 and my dimension is 12, I know that this is only one group of 12 to get me there. So now I'm at my 252 square feet and I can take my dimension up here, put it all together to see that this other dimension would be 21 feet long. So the way that we use this is we really kind of chip away using easier pieces to get to that total of 252 in this case. So that's one way to use an area model. So I am going to clear my board so that I can then show you an example of a ratio table. So imagine that Coach Green is planning field day and she's planning it for 280 students and she wants to put them into groups of 8 for the events. This would be a good problem to use a ratio table on. We could use the area model too, but I want to show you the second strategy we've been working on. And so when we use a ratio table, it's a 2-sided list, and we want to make sure that our headings match the units in the problem. So students would have heard that there were 280 students and that we want to make teams of 8. Team size. So we're going to use those units as our headings. So on one side, we're going to be concerned with the number of students. On one side, we're going to be concerned with the number of teams, I guess we could say. Number of students and number of teams. So I know that in one team, I have 8 students, and I always try to remind them to, as that entry point into this problem, to remind themselves about what they know. So for every one team, there are 8 students. And I'm going to start chipping away again using those landmark numbers just to get myself closer to that 280 students. That's my goal down there. If I can get to 280 students, I'll know how many teams that I have, and that's my answer. So I'll kind of put a star by this because that's what we're trying to aim for. So if I start out with, let's say, I'll start with, I could start with 10 teams, 8 students in each team, that would be 80 students. So I'm pretty far away at this point. I might try a doubling trick. So if I double on this side, then I can double this side. And so I know if I had 20 teams, that would be 160 students. So at this point, I'm still a ways away, but I'm wondering if I had 10 teams and 10 more teams, that would give me 30 teams. So if I put my 80 and my 160 together, I would have 240 students. So I'm now at 30 teams of 8, 240 students total. And I can see that I only have 40 more students to think about in this problem. So I'm always comparing to that end number. So if I have 40 students, how many 8s would that be? And this is where, if we know our multiplication facts, it's really helpful. So that would be 5 more teams. That would get me those 40 students. So altogether then, if I have 240 students and 40 students, I'm meeting my goal of 280 students. So if I have 30 teams and 5 more teams, I'm going to have 35 teams in these events to get my 280 students to participate. So using a ratio table, I kind of build in order to get to my goal, and I can go back and forward. It's a pretty fluid strategy. Again, this strategy is less visual than the area model. So the area model really is good for those of us like myself who need to kind of see the patterns. Whereas the ratio table really is well liked by kids who really think in numbers and know their facts really well. But both of these strategies are strategies that we're working on right now. They're really important strategies. And although, many of us would probably say like it's more efficient to just teach them the long division. Long division is pretty tricky. And if you don't understand like what you're doing and why you're doing it, it actually is not a very good strategy for a student. So we kind of build by finding these partial quotients in order to then transition that into long division, which I will show you when we make that next step towards long division. And that strategy is called partial quotients. So I just wanted to share that with you. I know as a parent, I like to kind of know what my kids are doing. And since these are strategies that will follow them into 5th grade, I thought it would be helpful for you to see what they look like and how we use them. So if you have any questions, please reach out and just ask, and I'm happy to either sit down with you in person or however it works to help you learn these if you'd like to. All right, thanks. Bye.